Networking concepts mainly we are looking at it from the point of view of the TCP/IP. Okay, how to make a TCP/IP connection from a Java. We actually are interested in writing a server. Okay, fine. Where our server will be able to listen for commands. Fine. Currently, we are giving commands from keyboard, right? So yes, we will have a server which is listening for commands not from the keyboard, but it should be getting it from across the network, right? So some network-based client should be able to connect to our server and give commands and get back the responses from the server. Okay. Fine. Okay, so with that intention, yes, we are looking at the networking part. Okay. So we are not looking at the whole of the networking API related, networking related API in Java. Okay. And typically only for TCP/IP connection. Okay. Okay, so let's begin with some concepts of networking. Right? Okay. Okay, so yeah, so what is networking? So what is the purpose of networking? So what is networking? Networking is about it's about communication, right? It's about communication between what? It's about communication between processes. Okay. But when someone talks about communication between processes, uh, another thing which would come to mind is, oh, we have the inter-process communication, right? And there are things like inter-process communication, which is with the help of the three main structures which will help you for inter-process communication. IPC might come to your mind, but here there's something additional. It's not about communication between processes within a machine. Okay, that's where yes, we'll talk of inter-process communication, right? But it's about communication between processes, fine, which may be on different machines. Different machines are there. And so it's not that inter-process communication, and it's not about the IPC. Just to check, yes, what are the things used for IPC? Anyone is aware? The most common things for IPC, inter-process communication. Two processes on same machine, it's known. How will they communicate? What are the different very common things used for inter-process communication?
TCP/IP, UDP?
No, it's inter-process communication within the machine. There's no networking. We are not talking about networking. When we say
UDP?
no networking, it's UDP is related to networking, right? It's so IPC, inter-process communication. I'm just asking, what is IPC, inter-process communication? What does it involve? You may be using queues, message. We call it as message queues. message queues, semaphores, and shared memory. Okay, these are the most common things which are, these are the most common things used for inter-process communication. And so that's what is very common. Okay, but we are not looking at this. Okay, it's not about this. When we are talking about networking, it is not, we are not talking related to the inter-process communication. Right? It's about communication between processes which may be on different machines, right? So it's something like this. Okay, so you got one machine. Okay, there's another machine. So we may have different machines. Okay, and on a machine we have so many processes, right? So there are some so many processes. So some process here would like to communicate with some other process on the other machine. Okay, we would like to have communication between two processes which may be on different machines, right? So what do we need for this? What are the requirements? How can this be achieved? Yeah. There are two machines, right? So what do we need? They need to be connected physically, and there has to be some media to connect them physically. When I say physically, it means some media, okay, where a connection is available, right? It may be through a wire, or even if it is a wireless, but some media is there, and which can be used for transmission and receiving, right? Transmit and receive something, some data. Okay, so we have what we call as a first thing. Oh, we have a you have something what we call as a OSI layers. If people are aware what is OSI layers for networking. When we talk of networking, yes, most commonly you start with the OSI layers. So yeah, which is the first layer for OSI?
Application on top.
Okay, because we are looking at the other way around, right?
Bottom, data, physical layer, bottom,
Physical layer. Okay, so let's start with this.
network above.
Okay, so what does physical layer mean here? It talks about you should have the required hardware. See, first requirement is if the two processes on two different machines, if they have to be communicating with each other and they have to be able to communicate, there has to be some hardware which is needed. Okay, when there has to be your appropriate hardware. So hardware is the first requirement, right? Okay, so when I say physical layer, okay, it talks of the hardware. Okay, a piece of hardware which is very important here is known as NIC. One of the hardware will be the NIC. It's a network interface card. Okay, when we normally have some networking interface. Okay, even if it's a Wi-Fi thing, fine. Still, there is some unit, fine, which is responsible for providing the wireless connection. Okay, so fine. So that is there is a hardware associated with the. So physical layer says, okay, we must have the appropriate hardware in place with us. Fine. Otherwise, so both the machines must have a network interface card, right? So maybe there's a network interface card here and here. This network interface card would use some kind of a media. Okay, it may be a UTP, fine, UTP cable or some other kind of a cable, right? Or maybe even if it's a wireless, but we have some media through which communication can take place between them. So we have a way where the two can be So physical hardware, we'll say, okay. That is, so physical layer is about this. Okay, fine. First requirement, yes, they must be physically be connected. Okay, what's the second? We have the
network interface.
data link.
Data link, sorry. Data link.
Okay. So what is this data link? And what is the data link layer? Oh, we have the network interface card here. So that's a physical hardware, right? But what is the role of this network interface card? Okay.
Mac, media access control.
Yeah. So what is
LSC.
yeah, what does it do in the communication? What is the role it is playing?
The multiplexing devices or
Okay. One of the things which it has to do, the most important part is,
error control and flow control in the physical layer.
okay, physical
And
layer
protocol.
is a connection, right? Maybe it's a wired or
Yeah.
wireless, whatever it is, right? But one thing, what is why this is there? What is it that we
Same,
would
it
like
has
to do?
same.
Yeah,
And node to node data transfer when you
data
have
transfer. Okay,
yes.
so basically it converts, the role of the network interface card is to convert data into signals.
Okay.
Okay, signal according to the media. Fine.
Hmm.
Okay. Clear. So it's a signal which the hardware will carry the signal for me. And the physical layer is giving us the hardware, and the data link layer is having the capability of using that hardware for sending data. Fine. Sending on the hardware, you'll be only able to set signals, and these signals will, so conversion of data to signal and signal to data. Okay, what kind of signal? Or that all depends on the kind of media which you are using. Okay, so there'll be a different kind of a network interface card needed depending on the media which you have. Fine. So the role, this is like converting data to signal and signal to data. Okay, but yes, here, see, when we talk of any communication, right, there has to be a mechanism of, there has to be some entity who is involved in the communication part, right? Oh, someone is sending data. Who is sending data? Who is the recipient of the data? And such information has to be there. So there has to be some kind of an identity related to the network interface card. So all your network interface cards, so this is at the data link layer. Okay, the network interface card will have a unique MAC address. Okay, so there is something called MAC address. Okay, this is related to the data link layer. So we have a MAC address. Okay, so yeah, so what is a MAC address? It's your unique identity available with the network interface card, right? So what's the size of the MAC address? MAC addresses are
128 bits.
48 bits.
48 bits.
Okay, 6 byte in all, right?
6 bits.
Out in this 48 bit, 24 bits is the initial 24 bits, most significant 24 bits will identify the manufacturer. Okay, in the next 24 bits, there will be some serial number used by the manufacturer. Fine. So 2 to the power of 24, so many machines, so many numbers, right? MAC addresses are possible for a manufacturer. Right? It's a huge number. Okay, Fine. So MAC addresses, yes. So if someone looks at a MAC addresses, yes, you should be able to identify who the manufacturer is by looking at the first 3 bytes. 24 bits is your fine, 3 bytes. So 3 plus 3, 6 bytes in all for the MAC address. So one thing we should know is, yes, we have a MAC address associated with our network interface card. Okay, so this is more closer to the physical networking card, right? Okay, now when we talk of communication, maybe one machine may have multiple kinds of network interface cards. Okay, so yeah, if we come back here, yeah, fine. There might be different. One machine may even be saying, okay, let me use more than one network interface card, one for fine. So now, what we would like is not the identification from the applications point of view, from the process point of view. The process is going to be running on a machine, right? So it doesn't matter uh, which interface I will be able to communicate to the other side, right? Okay, there will be different network interface card. Right? What matters to me is, oh, I'm going to communicate to a process on a given host. Oh, this is my host machine to whom I would like to communicate. It doesn't matter to me which MAC address it has. Right? When a process is trying to communicate, what it has to know, oh, I want to communicate with that process which is on a given host machine. MAC address is not important here to me. Right? Yeah, but MAC address is needed for that physical transfer of signals. Right? Okay, so what we have here is the next layer which we have after the data link layer is the network layer. The job is to have some kind of a unique identification for the machines, not for the network interface card. Network interface card will definitely have their own thing, but the machines need to be uniquely identified. Instead of using the term machine, now we use the term as host. Okay, fine. So hosts are identified. So the next layer, which is the network layer, fine. So network layer is about having identity for the hosts. Okay. Okay. So we have the network layer where it is unique identification of the hosts. Okay, all hosts should be uniquely identified. Now, another thing, if you look at it, the first layer, physical layer, is about hardware. Okay, what about the second layer, data link layer? Is it hardware? It is in the hardware, but it is a piece of a software which is hard coded, right? It's a fixed software. We call it as a firmware. And it's going to be in the ROM of the, see that how to convert from data into signal to data, fine. Okay, and having some fixed MAC address. So all that is burnt into a ROM. Okay, fine. So it would be in the ROM of the also such thing that this program basically is in the ROM of the network interface card, fine, and therefore this is known as firmware. Okay, fine. This layer, when we are talking of the networking layer, okay, this is a layer which is in the form of a software. Okay, so here you have got multiple options. Fine, there will be multiple, we call these as protocols. So there are multiple protocols available at the network layer. One of the popular protocol which is available at the network layer is the, okay, so for networking, yes, for the networking, one option is to use IP. So there is a IP protocol. Okay, fine. So we have this IP protocol for network layer. And this is the one which is most commonly used. Fine. As far as so if it is the IP which is very commonly used, yes. Now we also talked about that we have a unique identification for the hosts. We need a unique identification for the hosts. So in network layer, hosts are assigned IP addresses. So we have the concept of our IP address. Fine. IP addresses, yes. What is the size of an IP address? How many bits? It's a unique identification for a host now. Yeah. How many bits per IP address? Depends on the version. Okay. So IP addresses are, if we use IPv4, okay, this is
6.
32.
IPv4.
Fine, 32 bits, or you can say 4 byte. Okay. And we have
IPv6.
IPv6, and that is 128 bits. Okay, fine. So size of the IP addresses. Okay, so we might use IPv4 for our example, right? Okay, but exactly similar concept with the IPv6. Okay. So one thing, yes, what we have, what the network layer is also allowing us to do is, okay, we can have a group of hosts and say, oh, this forms a network. A group of hosts can be assigned a network. Okay, so network is nothing but a group of host machines. Okay, so we have here something like this. If I just consider that 32-bit thing, okay, fine. So you have your IP address, fine. An IP address is divided again into two parts. The most significant bits, we say, they are known as the network address. And we have the host within the network. Host within a network. Hosts belong to a network. Fine. So, yeah. So it's something like this. You got a network. I'll just put it this way. So there are multiple hosts in a network. Fine. And it's not that a particular machine will have only one identification. Fine. A particular machine may belong to more than one network also. So you can say, okay, we can have this machine also belonging to another network. So you have multiple hosts belonging to a network. Okay, so this is one network. So this is network 1, and this is your network 2. Okay, fine. So how do you identify by looking at the IP address whether a host belongs to this network or belongs to the other network? Okay. So for that, yes, we just look at the IP address, the initial bits. Now, how many bits will be used for network and how many bits will be left for the host within the network? So when we are saying, okay, we have network 1, and if we have decided that the number of bits for the network is going to be, maybe I'm using 16 bits, or maybe someone says, okay, let's use only 10 bits for the network. Suppose someone says, I want to use 10 bits for the network. Okay, that's also possible, right? So if someone says 10 bits for the network, it would mean that first 10 bits, okay, in the IP address for all the machines on this network, the first 10 bit is fixed. Okay, in this again, the other network also, they have decided to use the first 10 bits as the as a particular value. So for network 1, the first 10 bits will be one combination, fine, and for the network 2, there will be a different value for the first 10 bits. Okay, rest of the things belong to the host within the network. Okay, fine. So if you are setting up a host for networking, okay, it's not just that we set up the IP address. Along with the IP address, when you set up any IP address, okay, you'll also have to indicate how many bits in this IP address are used for identifying the network. Okay, fine. So the number of bits used for identification of the network, they can be indicated by using another value. Like we have one value which we call as the IP address. Okay, there is another value, same size value, which we call as the subnet mask. Okay, so we have a IP address and a subnet mask, two things. Fine. Okay. Now, okay, let's first talk about the IPv4 itself, 32-bit which we are using. So if you have 32 bits in an IP address, right? If your IP address has, sorry. So if the IP address has 32 bits, okay, we know it is made up of 4 bytes, right? There are 32 bits in an IP address, so we have 4 bytes, right? Each byte has got 8 bits, and therefore the range is from, we look at it as an unsigned byte value. So what is the decimal range? Fine, 0 to 255 for each byte, right? So each place you can have a value. Fine, each byte has a value of 0 to 255. So there are 4 bytes in an IPv4 IP address. Okay, and so so here we have a notation used for specifying an IP address. We call it as a decimal dotted notation. That means write each byte decimal value separated by dot. Okay, fine. Someone might say, okay, let me have a value of 179 in the first byte. Second byte, let me have a value, so dot 173.250. Okay, so yeah, 250.35. Right. So this is a IP address. Okay, this is some kind of an IP address. Okay, so what is IP address? In IPv4, when we say decimal dotted notation is being used to represent, IP address is simply a 32-bit number. But no, instead of remembering a large 32-bit number, it might be easier to remember 4 decimal values and 4 decimal numbers. Okay, fine. Typically, yes, the kind of IP addresses which you may be more used to, they would begin with 192.168. Okay, that's very common, right? And then dot, okay, one dot, and then, okay, something like this, 75. Okay, I'm just giving one example. Okay. And that's another example of a IP address. But I'm mentioning that there are two things when we put an IP address. First is this 32-bit value. And what is the second? Another 32-bit value to indicate how many bits are used for networking. Okay, so it's like this. We have IP address with 4 bytes. Okay, we got a subnet mask also having 4 bytes. Okay, but a subnet mask, the way these bits are used in the subnet mask is, in a subnet mask, the bits, initial most significant bits are ones. So it's a series of ones, okay, followed by a series of zeros. Okay, so initial most significant ones in a subnet mask indicate how many bits are for the networking. So you don't just give an IP address, along with the IP address you also indicate a subnet mask. The idea is to indicate how many bits are used for networking.
So if you want 8 for say FF00.
So you will say 255, 8 bits, you'll say 255.0.0.0. That's a subnet mask.
Okay.
Okay.
Okay. What about the ABCDEF? They're also used, right? Like
No,
decimal?
no.
No?
No.
It's always decimal. Okay.
Yeah. Okay. In the IPv6, yes, hex values are used.
Okay.
Fine.
Hmm.
So for IPv4, yes, we use it like we are writing decimal values, right? Okay. So yes, if it is 8 bits, yes, you'll say 255.0.0.0. That's a subnet mask to indicate that 8 bits for network. How many bits to be used for network? Okay. Someone wants to indicate 10 bits for the network. What will be the value?
255.1100.
So this is 8 bit. Okay. Yeah, if it is 10 bit, yeah, it will be first 8 bits here, next 2 bits are 1 and everything else is 0. So 128 plus 64,
232.
232.
No, 1 second. 9, 10, 212. 212?
No,
No.
128 plus 64.
Plus 60. 64. 12, 192. Sorry.
192.
192. 255.192.0.0.
That indicates 10 bit.
Okay.
If subnet mask is like this. Okay. Fine. So given a subnet mask, now if you want to find out, okay, so now, okay, for this subnet mask, yeah, if this is the subnet mask, okay, and okay, and let's say, yeah, so what you first decide is what are the 10 bits for one particular network 1. So let's say network 1 is there, okay, and network 1 says my identification, so it's a 10-bit identification we are dealing with now. I'm taking a case of 10 bits now, okay. Fine, which is not a normal thing. Normally we go with 8, 16 or 24 bit.
Okay.
Okay, but someone says, okay, we'll use 10 bits for the network. So first decide the 10 bits for the network. So network 1 says my first 10 bits are going to be, yeah. So he says, let me write in decimal. Okay. First byte he says is 192. Second byte, first two bits only I have to worry about, right? So what are the first two bits? Maybe 10, 11, 01 or 00. So what do we want to keep it? First 8 bits, okay, whatever that 192. So when I'm saying 192, it is 110000. Okay.
Yeah.
Fine. You want to keep a different value, that can be also fine. Okay. Fine. But what are the next two bits? Maybe we go with 01.
Zeros.
So what's the first two bits in the next byte? Do you want to keep it both of them 0, or you want to keep some other value? 10, 11 or 01?
101101.
What is it? Let's choose one of them.
Okay.
There are 4 things which are possible, right? We have only 2 more bits. First 8 bits I fixed out of the 10 bits. Okay. What are the next 2 bits you want to keep? Let's say we go with the 01.
Okay.
Okay. So 192 dot, what's my next value? Rest of the things will be zeros. Next 2 bits are
64.
Okay. So
64.
64.0.0. This is what is known as the network address.
Okay.
So if this is the network address, fine, and this is the where is it? Yeah, and so this is the subnet mask. Okay, and this being the network address. Fine. Now, what are the possible addresses, IP addresses in this network? The possible IP addresses in this network will be 192 dot. Now we have first 10 bits a fixed value. Fine.
Yeah.
Second byte has 01 in the beginning.
Yeah.
Okay, fine. Rest of the things, if they are 0, that is reserved as a network address.
Okay.
Okay. Similarly, if all the bits, host bits, are set to 1, it's known as a broadcast address. So 2 of those possible values are reserved, where all host part is all zeros, that's reserved, known as the network address. Host part is all ones, that's reserved, known as the broadcast address. Okay. So what are the possible IP addresses now? It will be 64.0.1. Okay, all zeros, that's a network address. So first IP address in this network would be this. And what's the highest IP address in this network? It goes from here up to 192 dot. Okay, so 01 and all ones. Next byte, it will be 127. Yeah. Dot 255 dot. If I make it 255, it would make it broadcast address. So it goes up to 254. Okay. So this is the range of valid network addresses in this network. Okay. Valid IP addresses for the network. What is the network? 192.64.0.0. Okay. Having a subnet mask of 255.192.0.0.
Okay.
Okay. Then this is the range of IP addresses. Valid IP addresses in that network.
If we had 192.64.1.0. 192.64.1.0.
Yeah, 1.0 is valid, right? It's in this range only.
Yeah, it is within this range.
Yeah.
Okay.
It's from 192.64.0.1, right, up to 192.127, from 64 to 127, second byte.
Seven.
Okay, third byte goes from 0 to 255. Fourth byte is again from 1 to 254.
4.
Okay, so IP addresses, fine. So network is about identifying the giving some identification to hosts. Okay, so communication would take place between machines which are part of the same network. Fine. Direct communication is between machines which are part of the same network. Any messaging which happens, okay, fine, will involve use of the IP addresses. See, it's like this. To the lower layer, what will be given is, okay, I want to send this message to so and so IP address. Okay, so source IP address, destination IP address, they will always be part of any message which is being sent. Okay. Fine. Source and destination IP addresses will have to be part of whatever is fine. So we always have identification of source and destination. Okay. So if I look at this again, so we have multiple networks, right? So we have one network and two network here. Okay. So when we have to configure, okay, so when we configure IP addresses, so this has one set of IP addresses, network 2 has another set of IP addresses. Okay, now one thing what we find here is there is one machine which is configured with multiple IP addresses. Okay, it has an IP address which is in the local network here. Okay, and it has an IP address also available for another network. So there are more than one IP addresses in this particular host. So this is one host which is having multiple IP addresses. Okay, now when any message is sent, you know, a process will say, I want to send a message. So on this host, some process says, I want to send a message to so and so IP address. Okay, it uses an IP address and says, oh, I want to send a message to this IP address. Now, if that IP address, destination IP address, happens to be in the same network, in that case, it's always going to be able to communicate with it. Right? But if that IP address, the destination IP address, happens to be in a different host, then it can't communicate. Fine. If the destination host is in a different network, then it will not be able to. It's not in the local address. It's not in the network address is not the same. Destination network address is not the same. Fine. In that case, communication cannot happen unless on this machine there is one more configuration. So every machine is configured with two things, right? First is IP address and a subnet mask, just to indicate how many bits are the network. There's a third setting also which is used. Okay, this is nothing but, okay, so let's say if this is the host which is being configured, it will have to be told that if there are any messages meant for outside the network, outside your current network, then they have to be sent via this particular host. So there is one host in your network which we may call as a gateway or a router. Okay, so there is a router. Router is the one which is participating in more than one network. Routers will be participating in more than one network. So they will have multiple IP addresses. One IP address which is local, another IP address which is in the fine, which is for the other network. Okay. Fine. So now, if any, so when a process here says I want to send an IP a message to some and gives a destination IP address. If the destination happens to be in a different network, then what it will look at is a third setting, right? There is a third setting also. So there is a setting of what we call as a gateway. So we have a gateway address. So gateway address is also needed to be set on your machine. Okay, fine. So if a gateway address is also going to be a local address. So it's nothing but locally on this side, if this is my router, so on router there is one side which is my local side, and other side is the there may be more than one also, right? So router is connected to maybe multiple, has so many IP addresses and connected to multiple networks, and or maybe even it's another network, at least one more network, right? Okay, so in that case, if anything is to be communicated, and it will be outside the network, it will always be routed via this. Therefore, this address where I should do, who will do the routing for me? Okay, when that is what is configured when we are saying there is a gateway address. So gateway address is the address of the host who will be doing the routing part. Okay. Fine, clear on this? Okay. Okay. Fine. I'll just quickly show you. Let me just check on my local machine what's the setting here. Right. So if you want to check the IP addresses for your machine, fine. There is one command called ipconfig. Yeah. So we have this ipconfig command. Okay, and it tells us a lot of information. Okay, so there are different adapters available on my machine. So one of them is this wireless LAN adapter. There is Wi-Fi 2, IPv4 address 192.168.0 dot this. Okay, fine. A subnet mask is available, and oh, I have a gateway. Fine, there is a gateway which is 192.168.0.1. See how many bits are used for the network in this case? How many bits are used for the network?
1 second, 1 second. 64, matlab,
This is your
they
subnet
use
mask.
10.
This is the subnet mask here. This
Yeah.
line. Yeah. That's the subnet mask. So how many bits for the network?
Twenty-four bits.
24 bits for the network. Okay. Fine. Okay. Now let me use a command like this. Let me use the option of /a. I think that's for all information. Let's look at it again. /all. Okay. Fine. Now with /all, yes, it's able to give me more information, and let's check this now. So Wi-Fi 2, fine. Here it's saying physical address. What is this physical address?
MAC address.
That's a MAC address. 6-byte MAC address. Okay. Okay. There are other information, but yes, this is my and this is my IP address. Okay, that's going to be the subnet mask. Okay, gateway. Okay, fine. Okay,
Is gateway and DNS?
No, okay. Here the gateway is configured for DNS also, but basically DNS, this is just, it's not a, it's your local DNS kind of. Okay.
It's not the router or DNS में कोई explain this again.
Yeah, DNS,
Then router.
okay. Here your router is also configured as a DNS, but this DNS is a protocol where it's a hierarchical protocol. The things are in a
Okay.
hierarchy, and therefore the your router is basically also dependent on another DNS.
Okay. So router and DNS are two different
Yes. Yes.
computers.
Yeah, we could have configured the DNS server directly instead of going via the router.
Router, got it. Domain name server.
Yes, domain name server.
Or DHCP Dynamic Host Control Protocol.
Yeah.
क्या करता है वो? It gives you different addresses, IP addresses.
Okay, so when a machine starts, fine, when you put on a machine, power on a machine, fine, and you may not have configured it for networking in the sense that you don't give an IP address and subnet mask and gateway address, everything to the machine. Okay, you have not configured it, fine, but you have let it be configured via DHCP, Dynamic Host Configuration Protocol. So it's like when the machine would start, fine, it will just check if there is someone DHCP server which is available. Okay, so it broadcast a message, and if there is a DHCP server, it will respond, and then the DHCP server will let it know that this is the unique IP address in my network which I have not allocated to anyone else. Okay, so it can then use that particular IP address. Okay, so this machine has been configured via the DHCP. Yeah.
Got it. Sir, उसके ऊपर जो लिखा है IAID DHCP V6, this is very new to me.
DHCP V6, yeah. This is our DHCP. So it is V6 basically. It's IPv6 based.
Okay, but IAID का problem.
I'm not sure.
We are also not sure. I've never seen this before. Okay.
Okay. Fine.
Okay, thank you.
Fine. So clear on this? Okay.
Sir, यहाँ
Fine,
पे
so
भी
network.
आपके adapted, media connected लिखा है, but this is all you have. You have only two things. One is disconnected, one is connected, right? Your Ethernet is disconnected here.
Yeah, I have not put anything on the Ethernet port. Okay. So we have the option of connecting via the Ethernet port also, right? Okay. And there are some, virtual adapters which have been created.
Okay. Some of my machines, 5 adapters, whether only one is connected or not, I don't know what the other 4 are. Okay.
Okay, so that's the LAN connection one. See, this one it says is Ethernet adapter, right? That's a Realtek, fine. But then there is a wireless LAN adapter, LAN 1, and this one, see, it's a virtual one because it's configured via Microsoft Wi-Fi Direct Virtual Adapter. Okay.
Okay.
Fine. So they would have assigned some DHCP, not DHCP, this the MAC
आपका
address.
fully wired चल रहा है, Ethernet आपका सब connected है.
हाँ.
Okay. I mean, nobody uses Ethernet except for bootstrapping first time. Okay.
Okay. Fine.
Okay. But one last question: can you figure out from an IP address which country the computer is in?
Okay. Actually, there are places where this information is available, which set of IP addresses have been available through to which particular country. So country wise, you can look for IP address to location, okay, and that will tell you. It tells you much more, not only the country, it tells you much more which area it is in.
So dynamic or static जो addressing होता है, if you have time someday take me to photos. Static addresses don't change, right? Each time we turn off and turn off.
Okay, okay.
IP address, how can we find location? If we connect any VPN, then it will change.
Yeah, if it is VPN, then of course, that is how you secure. Okay.
ये लोग VPN use कर रहे हैं students?
नहीं, in company.
Company में VPN. Privately खरीद सकते हैं क्या ये सर?
Yeah, you can subscribe. Anyone can subscribe for the VPN.
Okay.
Subscription based.
क्या है?
Identity. And
Identity. Okay.
okay, so network layer, yes, the things to be configured and the network layer. Fine, three things. Okay, IP address, subnet mask, and the gateway address. Fine. So, so now we are at a layer where identification of host is available. Fine. So we have a mechanism where the things are available. Fine. And the next layer, yeah, what's the next layer? After the network layer,
Transport layer.
you have the transport layer. Okay. So since we are looking at it from the point of TCP/IP, fine, we will not have the 7 OSI layers, but we'll have only 5 layers. Okay. The fourth one here is the transport layer. If now we are also dependent on, so we have looked at IP part, right? So if we have IP at the network layer is used, IP is used as a network layer, okay, then there are two common options. There are many options, but the most common options, two common options available for transport layer. Okay, there is one called TCP, other is called UDP. So there are two options available. Fine. If you use TCP, we commonly term it as TCP over IP. Fine. We call it as TCP over IP. And TCP on top of the IP protocol. Okay, working on top of IP. Right? Or you might, okay, so we have TCP and UDP as the two most common options. Right? Our interest will be in the, from Java, what we would like to use is the TCP. Right? Okay, but there is an option of UDP also. What's the difference between TCP and UDP? Yeah,
you don't need the source and destination for UDP. You need it for TCP.
Okay. Okay. So yeah, what is this? Yeah, TCP. You do TCP is a
transmission control protocol.
Okay, it is connection oriented.
Okay.
Okay, fine. It is a connection oriented. It is stream based. Important. It's a stream based connection. Fine. And therefore we say, okay, it's a reliable protocol, fine, where we'll have this is considered as reliable because anything, if it is disconnected, yes, we'll know there is no connection or anything, right? Well, what is UDP?
User datagram protocol.
Okay. How does it compare with TCP? Connectionless. Right? It's going to be connectionless. Instead of stream based, it's a packet based protocol. Okay, fine. So see one thing, what we'll have above the transport layer, on top of it will be the application layer?
No session layer.
Yeah. Okay. That's when you look at it from the OSI point of view. We are looking at it from the TCP/IP point of view.
TCP point of view. Got it.
Right. So, what is the role played by the transport layer? If we consider those TCP and UDP options, yeah. So, what is TCP? It's like a phone connection. What is UDP? Phone connection is a stream based. Fine. And what is UDP?
DNS.
DNS is a protocol on top of these. It would use TCP or UDP also. And it uses both of them. Okay.
So what is UDP? UDP
How do you
system?
compare? Like if I say TCP is like a telephone, what is UDP like?
Oh, compare. Okay, got it. Got it. Is it like Telegram and fax or something?
Fine. It's like your mail send snail mail you can say. Fine. It's like
So,
fine. You want to send
Oh.
some fine. See. Fine. See
postal service.
yeah, postal service. It's like a postal service.
Got it. Got it. And TCP is like telephone.
It's like a
Okay.
telephone. Okay.
Okay. Okay.
Fine. Okay. Anyway, just as a comparison to understand that yes, if you are sending fine in a phone call, we understand, right? If it gets disconnected, we can know. Fine. We can then again retransmit the whole thing again. Fine. Okay. In case of UDP, fine. In case of postal, you put an address on a, you prepare a packet, put the address of the destination and put it in a box and then forget. Right?
Yeah.
You would not know when it has reached, whether it has reached or not. Fine, that would not be known. Right? It's a packet which is being prepared and stamped and sent. That's it.
Yeah.
Then it's there's nothing you can rely on. Okay, unless the application on top, which is on top of it, fine, is having a mechanism where it is going to send back a reply on receipt. Okay, it has to be done. Send back another packet back saying, okay, I have received your things, fine. Or whatever the answers may be, right? So it's like a query and a response through packets. Whereas it's a stream based. When we say TCP, it's a stream based. See, stream based, we just saw IO streams. Fine. So it's just going to be like that. You are going to be reading and writing continuous things. Okay. And so when we say TCP, yes, it's going to be about reading and writing now. Okay, reading and writing data. Okay, fine. You don't have to prepare one packet and then send it. Okay, now as far as transport layer is giving us a mechanism where two processes can exchange bytes. Okay, two processes can exchange bytes. Clear? We get so even if it's a TCP connection, yes, we get a byte based connection, and byte oriented connection is there. Okay, a stream of bytes. Fine. So transport layer is providing us the mechanism for two processes to be able to exchange bytes. Okay. So what's the application layer then? Yeah, what's the application layer doing?
Whatever the user is in contact with, can it be a web browser?
See, it's when we say that transport layer is giving us a mechanism, right, where bytes can be exchanged. It's like it's setting up a phone for me, right? Okay, so I have got a phone connection. I made a phone connection to someone, but does it mean there is a communication? Does it mean that communication will happen? Right? You can set up a call to someone in China and speak in Hindi. Is there communication? Yes, the voice is going, right? He is speaking something, that voice is coming back, but there's no communication. Okay. Clear? The transport layer is there, the mechanism is there, that exchange can take place, bytes can be exchanged, but then they have to have a meaning which is understood by both of them. Okay, that's where the application protocol comes in. Okay, so what is application protocol? It is some pre-decided mechanism that if I send this, this is how it is to be understood. Fine. The meanings are set for what kind of bytes are possible to be sent from one side, and how the other side, if the response is coming in this manner, how those bytes will have to be interpretation. Okay, so interpretation of the bytes is available on both the sides. Okay, bytes which will be received and what kind of bytes I have to send. So there is some predefined grammatical rules according to which the exchange of bytes will take place. Okay, that's where the application comes in, right? Okay, we have already done something on this line. We have set up some syntaxes for the commands which we can send, and the responses which come from the other side. Our commands in the bank clerk which we have set up. Okay, so we can use that as a protocol. Yeah, if I send open command, I should be getting back a response which gives me the details of the account which has been opened. They are separated by comma. They have a particular format in which it is coming, right? We have the toString method to give us that format, right? Okay, so fine. So this can be used for that purpose. Fine. Yeah. So we have a definite set of commands, right? So we have our own protocol here. Okay. Fine. So we would like to use that for our application. And okay, so thing to be done is fine. So in Java, how do we use this TCP connection? How do we make a TCP connection in Java? Another thing, when we look at the transport layer and when we talk of TCP, okay, the communication which happens is normally going to be, the TCP connection is always between two kinds of processes. There are two kinds of processes which are involved in a TCP connection. Okay, so two kinds of processes. What are those two kinds of processes? They have a specific role which they play. One we call as a server, and other side would be a client. Client server communication, right? Okay, so when someone says client and server, what is the impression we get? Client server. Oh, there is a process which is a client. Okay, let me put it on this side. So here is a server process and here is a client process.
The server provides the services the client uses.
Yes, fine. So server has to provide services and the client will be able to use those services. So who will initiate the connection?
The client.
Right? So client is always the initiator of the connection. Okay, client always initiates the connection. Server is always in a listening mode. And server is always going to be in a listening mode. Okay, fine. Okay, so yeah, as far as okay, now let's try to understand. Let me try to put an analogy here, fine, related to the, we started with that analogy of TCP IP communication is similar to the telephone based connection. Okay, now here I'm assuming our landline connections. Okay, fine, and yeah, so we have this landline connections, right? So we know we get numbers, right? We get a phone number. Okay, and how do we get a phone number? You can look at it something like this. Okay,
Yeah, assigned.
okay. I'll put it like this. We have a place. Okay, this is one town. A host is like a town. A host machine is like a town. Fine. The processes are like the persons in that town. Okay, on a host we have various processes. They are like the persons. Okay, fine. So maybe there are two hosts. So there are two different towns. Okay, and they have got the very multiple people who are available in that town. Right? So one person. Okay. Now again, I have to first talk about the server side. Okay, let me just say server side. So when we say server, it's nothing but someone who is giving a service. Okay, someone who is giving a service. So in our real life also, right, in this analogy which we are taking, we have got various services which are available, right? If there is an emergency on the highway, we use that 108, right? Fine, we use 108, right? We know this number. Okay, fine. Now 108 is a service, right? 108 is a service for any emergency on the highway, right? So if you have any emergency on the highway, you have a 108 service. Fine. So now who initiates the communication? The client, fine. And 108 is always in a listening mode. 108 is always going to be in a listening mode. Fine. You have to connect to the client. An important thing, we have this number 108, which is a standard number. It is a standard number known to all. The idea here, what I'm indicating here is the client should be having should have the knowledge about the number of the server. Server have a fixed number. Server will have a fixed number on which it is giving a service. Okay. Of course, there are various hosts on which a similar service will be available in a different town, right? Another same service will be available. Okay, there are multiple such places where this service. So each host, right, has a set of a set of processes. Some process, if that host has a server process, then okay, now let me talk about how a server process starts. Okay, when a server process starts, okay, we have host being identified by IP address. Okay, IP address is identifying the host. Okay, now when a server process starts on that, this server process will need one unique number. It's like within a town, I take a phone number. So within this host, I take what we call as a port number. Okay, so there is a port number which it will have to acquire. It acquires a port and then uses it. So we have for TCP connections, fine. In a TCP IP communication, we have a port number similar to a phone number. So port number is similar to a phone number. IP address is similar to the town code, STD code. And we have the STD code, right? Fine. Each, if you are using the landlines, right? Each town is identified by that initial number, right? We have, if you are fine. So IP address is like the STD code and code for that town. Okay, STD code. Okay, and port number is like the phone number. Okay, phone number within that town, right? So if I have to identify something in Baroda, then it will be, oh, it has to start with 0265, right? So that is your STD code. Fine, that's like the IP address. And phone number, that's like the port number. Fine, port numbers. So now standard services would normally start on a standard number. They have been given a standard number. Right? So okay, now let's talk about some server processes which are very commonly found. Some of the common servers you may come across is you may come across a server called the web server, or we say HTTP server, web or the HTTP server. Okay, so if it is web or HTTP server, then it normally starts on port number 80.
80?
HTTP
Okay.
HTTP would be on port number 80.
Okay.
Okay, fine. Same way, we have other services like, we have a FTP service. FTP normally starts on port number
16.
21.
Telnet is 23. Yeah.
Telnet is 23. Yes, you have a Telnet service also, that is, so that's a Telnet. There's a POP3, 110 for POP3.
110. SMTP?
25 for SMTP. Simple mail transfer protocol. Fine, it's for sending mail basically. Okay. Fine. Normally we are used to using the web-based mail interfaces, but behind the scene, those the communication, right? Mails are exchanged by using SMTP. So sending of mail is done with the SMTP. Receiving of mail, checking your mailbox, that's involving POP3. Okay. Another protocol which is more popular now, okay, which does both the things, is IMAP. I'm not sure about the port number, okay, but there is an IMAP protocol also.
What does it stand for?
I'm not sure. It's related to the mail and it's taking care of sending and receiving both.
Mail access protocol. Okay. Internet mail access protocol.
I'm not sure. You can check.
Yes.
Okay.
We can still use
So
POP3 and SMTP to configure our web browser.
Yeah, we can configure. So, for example, some of the mail clients which we can use, where all these options of using POP3, SMTP, and IMAP are available. We can use. One is Thunderbird. On Windows, you can use the Outlook Express. But yeah.
Okay.
So Outlook Express. Okay, so these are some applications, right, which make use of the for mail purpose. Anyway, so one thing, let's look at that part, right, server part. So now let's understand how a server works. Okay, when you start a server process, okay, just before that, one more point. I'm talking about port numbers, right? What is the valid range for port numbers? So port numbers are 16-bit values. Port number is a 16-bit value. Okay, range is from, so 0 has been reserved, port number 0 is reserved, so you have 1 to 65535. That's a range for port numbers. Okay, so port numbers ranges from 1 to 65535, and okay, fine. So and out of this, in this range, less than 1024, less than 1024 are privileged ports. There are the privileged ports available for use to admin role only. So unless you are the process is started with admin role, it won't be able to use them. Fine. So coming to how a server now normally works. So when a server starts, the first thing it does, it has to be started with some fixed port number in mind, right? So when you say, okay, I want to start a HTTP server, let's say, for example, we say, oh, let me start an HTTP server. So when you start the HTTP server, the default configuration for it would be start on port number 80.
Yeah.
Okay, you can overrule, you can change the configurations. I would like to start on a different port. So whatever port it has been configured for. Okay, so when the HTTP server would start, it will go to the OS and say, oh, give me port number 80. I'm just saying 80, it could be what. So a given server has to always start with a fixed port number in mind, right? It has to be configured with a particular port number. So when you start that process, it has to go to the OS and say, reserve this for me. I want this number. What happens if that number is already allocated to someone else? What would happen?
Conflict.
Right? So in that case, the server will be told that your request for that number is not allowed. It's already used by someone, and the server normally would not start and would just stop. Okay, so I can't be started. This someone else is already using this number. Right? So any server process always starts and he says, okay, give me a number, and it will just start listening on that number. So server starting is like this. Okay, when you start a server, it starts with a fixed port number.
What is port 0 reserved for?
Okay, so when you say try to use port 0, yes, you'll request port 0. That means any available, whatever is the available number, that should be given.
Okay.
Okay, now how about a client? So this is how the server would work. Okay, how about a client? When a client starts, right, and client now says, oh, I would like to talk to a server, right? It says, I would like to talk to a server. So what are the things needed by this client? What are the information which is needed by a client?
The server's address,
Yeah, needs,
port number,
okay, IP address and port number of the server. Okay, so that's where I know I have to connect here. But in order to connect, I must have a phone. I must have my phone number only, then I can talk to someone. Okay, so what it does, so before it can talk here, and it says I intend to talk here. So what, but before it can talk, what it should know, it has to go to the OS and say, give me some number, give me some port number. I want to talk. I want to use this. Fine. So it's just like, in the earlier days, phone was actually a very privileged thing in India. Okay. Okay. So we had to actually make a application to your telephone department and then say, and then there'll be a queue and then you will be allocated a number, right? So you have to have a number before you can talk. Okay, fine. So this is what is, so client will have a number. Okay, client also will have a port number. Okay, but it's not a number which the client is asking. Client doesn't ask for, I need that number. No, it's not that way. Client is saying, okay, give me some number. I have to talk. Okay. Fine. So client gets allocated a number and then it is able to communicate here to a server. Okay. Another thing, now I'll show you just one more information which is related to the server here. Okay. I've seen a place in the telephone exchange, how they work. Okay, how they give a service. There is a service which was available before those things. There is a service, the number was 180. Okay, this was used for trunk call services.
Yes.
Okay, fine. So how the trunk call used to work was, I'm not looking into that, but this service, how it was being given, because so when I look at the place where in the exchange where this service was given, okay, how it was working was like this. There'll be a set of operators. It's not just one person. There is a set of operators who are sitting in a room. Okay, there's a big room in which they are, I should say it's a big hall where they are all sitting. Okay, and when someone dials 180, okay, they had basically in the corner, they had a set of lamps which would be there. So when someone would dial 180, one of the lamp would glow. Okay, so then there is someone, some client who is coming here, right? So when a lamp would glow, one of the operators here will say, okay, I'll handle this client. It's one of the operators here, he'll say, oh, let me handle this client. He'll take and start the communication part. While this communication is going on this number 180, someone else is dialing 180. Okay, another lamp would glow. Fine. On that same number, multiple connections are getting handled simultaneously. Okay, it's another operator who has to handle it. Okay, fine. The number is 180, but there are multiple operators who will be able to handle that. Okay, fine. Now let me talk about Java related things. Okay, yeah. I'll just mention the names of the classes involved here. So in Java, there are two classes which will be useful from the, so we have this package called the java.net package. And there are classes, one is a class called server socket and other is the class called socket. Okay. Fine. Socket is more like a phone connection, phone. And this is like, if there is a server, right? When someone is giving a service, they use a board, right? Where the calls will land. Okay. The calls land on a board, right? And then some operator will handle it. So we can look at it as the board. Server socket is like the board. And ultimately, communication doesn't happen from board to the phone. It is from phone to a phone. Okay. Communication is between two phones. So on this side also, the operator has to have a phone. Okay. And phone has two important things for functional part. Two important functional parts related to a phone, a transmitter and a receiver. and a transmitter and a receiver. What is the transmitter in a socket? What's a receiver in the socket? It's a input stream. So transmitter is our output stream, receiver is our input stream. So what we would be using is, we will be using a socket for our communication. From a socket, we should be able to obtain an input stream and output stream. If you want to send something, we'll write on the output stream. If we have to listen to what is coming from the other side, we have to use the input stream, read on the input stream. Fine, fine. We'll see that tomorrow. Okay. Yeah. So tomorrow we'll look into this, and yeah. So from Java, how do we use it now? Okay. And so we'll make our server as a network-based server now. Okay. We have that. We have created a bank clerk, right? But then how do we use it? Okay. Let's. And so tomorrow we'll use it on network. Okay. Continue tomorrow.